Okay, we have a lot of content to go through today, so I'll be starting now, I guess. All right, so today we'll be talking about strings. So we actually went over strings earlier in a previous class, but I wanted to reiterate what a string was basically. So here's a quick review. So a string is defined as a sequence or array of characters, and each character is a key on a keyboard, for example, A, B, C, D, E, F, G, or like 1, 2, 3, or maybe an @ sign or a question mark or something like that. So examples would be like hello or Java 1, 2, 3. And I included Java 1, 2, 3 because it shows that numbers and other symbols can be considered as characters as well. A sequence of characters is also referred to as an array of characters, but we have not learned arrays yet. So this will make sense to you guys probably later on. So as I mentioned before, when I first introduced strings as one of the variable types you should know, I said that strings are an object rather than a primitive. And what this means is it means two things. And one of the things that it means is that as it is an object, it has some innate built-in methods by Java that we can call upon and use. So the focus of this lesson will be learning how to use the methods that come along with the string concept. However, I want to note one more thing, which I said before, is that initializing a string it is initialized as a primitive. So instead of doing something like string name equals new string, Bob, you can simply set a string name equal to the string value directly, which is how you define variables for primitives, but you can do it for a string as well, even though it is an object. So here is an example of how to create a string variable and set it to a value. So does anyone have any quick questions about like this quick review of stuff that we should probably already know? Okay, so no? Okay, I'll go on then. So I wanted to go over a few definitions that I'll be using later on and probably during this class as well. So a string is what we call a reference type. So when we create a variable, it is called a reference variable. So a primitive, what is a primitive? A primitive is the value that is directly assigned to a variable. And instead of a memory allocation, the primitive is numbers like, I don't know, 1, 2, 3, 4, 5, or like an integer or like a real number or something like that. So it's not an object because there's no separate memory space located to it, and a primitive can be changed and it's only linked to the variable. And please do not send uninstructive or I don't know, off-topic messages to the chat. I do not appreciate that. Okay, so I'll go on now. So when we create a variable, it contains a reference to the object as opposed to like it being the object itself. So instead of the primitive, which a variable is the number or value that it is assigned to after the assignment is done, an object or a string variable is a reference variable, and it only points to the memory space containing the string. So when we create a string called name or something like that, and we set it equal to Bob, Bob has a separate memory storage containing it, and our variable name only points to it. And there are a few things that this entails. Basically, it means that the value of a string is immutable, which means that it cannot be changed after it is created. Okay, so obviously this does not mean like we cannot change the variable x1 from Bob to like another value or something like that, but it means that I will explain. It means that if we set one variable equal to another, for example, in this, okay, these are variables x1 and x2. We define x1 as equal to Bob, and if we set x2 equal to x1, then x2 also contains a pointer to Bob. However, because it is a string instead of a primitive, if we set x1 equal to Joe, x2 does not change. Because x2 points to a memory value and does not point to the actual value of x1. So if x1 changes, x2 does not change. This differs from like a regular primitive. For example, if I said created a value x and y, I set x equal to 1 and y equals to x, then y would be equal to 1. And if you change x, y would also change with it. Right? What do you mean not actual? I don't know. I don't understand that question very well. So basically, when we create a variable, it is not the variable itself is not the value it is assigned to. It only refers to the created value that is in the memory space. So if we change one value, any values that are assigned to it does not change with it. Why does x2 equal Bob? Okay, so if we set x1 pointing to Bob, if we set x2 is equal to x1, then x2 is also by definition pointing to the same value that x1 points to. However, if we change x1 to a different value, x2 still points to the original value. Okay, so I'll prove that this works. So this is basically the code representing the chart from the previous slide. So I created a string x1 and we called it Bob. If we create a new string x2 and we set it equal to x1, then x2 now also contains the value Bob. We treat variables as a container, sort of. So x1 now contains the set of characters called Bob, right? However, because it is a string instead of a primitive, if we change the value of x1 from like Bob to Joe, where like it could be any other value, it could be like computer science or like Java or any set of characters. Basically, the point is that x2 does not change. So that's basically the definition of the immutability of objects. And we can see here that if we print out x1, x1 is Joe, but x2 does not print out Joe, instead prints out Bob. Okay, so any question? What does Joe do in my slideshow chart? It doesn't do anything. It's basically just a word. Okay, so if you're here during previous lessons, you should know that we can assign a value to a variable, and in this instance, a value could be anything from a number to like a word, or like even a Boolean. A Boolean basically true and false. So from a previous class, we know that there are many variable types, and that all of these variable types can be represented when we define a new variable. So in this instance, this Joe could be a name or whatever, and x2 would hold the value of Joe so that we can use it later on. Hopefully that makes sense. Okay, so I'm going to go over some string methods, which is the bulk of this class, because we need to be able to utilize the resources that we have that Java has provided to us. Yeah. So here I have a link on the slides. The slides are all posted in Google Classroom, so you can actually access this link, I think. This contains all of the, most of the building methods to string, but I'm going to go over most of the important ones. Some of the methods, string methods within the website I haven't used, so clearly a lot of them are like not useful, I guess. So the first one is the constructor method. This one's pretty useless. This is in general when we construct any object, the format would be something like string name would equal to new string, and then the value assigned to the string. For example, if we create like from our previous class a parrot object or like a bird object, it would be like bird name equals bird, like bird1 equals to new bird, and then whatever parameters of the bird. But the parameters of a string in this instance is a set of characters, as I mentioned before. However, this, as I said earlier, this is kind of a useless method because, as I mentioned in the beginning of the slide, Java has made it so that strings can be declared. String variables can be declared using the primitive declaration. So this is actually not needed. Yes, this will be recorded and posted on YouTube. Okay, so the next method I want to go over is the equals method. So equals str. Str stands for some string variable or value that the method requires as an input. We went over this when we talked about methods earlier. Method needs an input and output, and the input type for this instance would be a string. So we represent it as str. So briefly, what the equals method does is that it compares two strings and returns a Boolean value. And so if the two strings are equivalent to each other, it returns true, and if they're not equal to each other, it returns false. And this allows us to compare two strings really easily to see if they are the exact same. So for my example, I did Bob dot equals Joe, and this returns false because Bob and Joe are two different strings because they contain a different set of characters or characters in a different order. And so I put a caution here. Do not use the equals to compare two strings. So as we mentioned earlier from last class, when we compare two primitive variables, we can use the equals sign. However, for example, like is 1 equal to 2? If 1 is equal to 2, we would be like 1 equals 2, and then we'll give a true or false value. However, this does not apply to strings. So if you do the equals with two strings, it does not work as intended. So it is better to use the dot equals method. Yeah. So to call upon a method, you use the dot and then the method name followed by any method parameters. The method parameter in this instance would be a string value, so I represent it with str. And for the next method we were talking about, there are no parameters, so the parentheses have nothing in them. Okay, so the next method that I'll be going over is the length method, and it returns the character length of a string. So for example, bob.length would return the value of 3. This is because there are 3 characters in Bob, B, O, and B. So the length of the string would be 3. It's pretty self-explanatory, but exists. So any questions? Also, note that I did not create any variables representing Bob or Joe in this instance. I just directly wrote the strings themselves. However, if I created a variable called name and I set it equal to Bob and I did name dot equals Joe, it would still run the same as intended. So every single instance where, can I post the link in the slideshow? What link? So every instance of Bob here can be replaced with a variable that refers to Bob under string methods. Yes. Wait, are you talking about, I'm not sure if you can see my cursor. Okay, I have a pointer now. Are you talking about this? Yes, okay, yeah. I'll post in the Zoom chat, and also I will be posting this slides in the Google Classroom later on. So you guys will be able to view it there as well. So you guys probably have that link. But it's also not necessary because I will be going over all the important methods. So are there any other questions? These three methods are relatively simple, so I'll move on. Okay, the next method I want to talk about is the index of method. So we know from our definition that a string contains a set of characters, correct? However, this set of characters could have within it another subset of characters. And so this subset of characters we refer to as a substring. So if we do index of str, where str represents some substring, we can find the index of the first occurrence of the substring within another string, right? So for example, the word vision occurs in television, right? So therefore, there has to be a first instance of which television vision occurs in television. And to calculate the index of this first occurrence, we can use the bottom table to see how it works. So each character within television is assigned an index or a value representing its order. So in this instance, the T is the first one, so it's 0. The E is the second one, so it's 1. So it basically starts from its position -1, P -1. So it'll be, you can see the top goes from 0 to 9, and then television is just spelled as normally. So therefore, every index of the word television contains a character, an individual character. And what index of basically does is that it returns the index of the first letter of vision within television. So we see that vision exists within television, and the first value that is shared between the both is v, and the index of v is 4, so it would return 4 as I said here. And sometimes some words don't exist within another word. For example, Bob is not present in television, so therefore it cannot return the index of a first occurrence of the string within another string because it simply does not exist. So in this instance, it returns -1. And in general, for most methods that are built into Java, if it does not work as intended, or whatever it's trying to find does not exist, it would return a -1 just to basically symbolize like something went wrong. Also, the return value of this method index of would be an integer, because you can see that it always returns an integer at whether some positive number or a negative number in this instance of -1. So does anyone have any questions about that? Okay, so you guys might still be confused because index of is kind of complicated, I guess. So I'll give you guys a practice question right now. So if I did television.index of instead of vision, I did Sion, S-I-O-N, what would the return value be? You guys can type your answers to me in the chat. Okay, I will type the question here. Shoot. So if I changed it from vision to SION, what would the return value be? That is the question. Returns question mark. Okay, so I got a couple of answers. So 4 would be incorrect because the first letter of S does not occur at the index of 4. The first instance of S within the substring scion occurs here. So it would be 6. And notice that 6, 7, 8, 9 does not work because 6, 7, 8, 9 would represent 6,789, and there are not even that many. The string length of television is only 9, so it has to be a number within 0 to 9, including -1. So basically picks the first instance of a shared character within both, and it outputs the index of it. Okay, so great. Looks like at least a good portion of you guys understand. So I'll move on. Okay, so going off of the same format of assigning index values to the characters within the string, we define 2 more methods, which are substring with a start index and an end index, and a substring with just a start index. So basically what substring does is that returns a substring containing the characters within the start index and the index and end index of another string. So for this instance, if we have a string Bob the Builder and we wanted to take the characters from some portion of Bob the Builder, right? For example, I don't know, maybe I want Bob or maybe I want Builder instead of the entire word. I can use a method called substring. So if we know the starting index and the end index of whatever word we want, we can find the word within the word, find the substring within the string, initial string, and output it. So for this instance, if we do Bob the Builder substring 36, basically what this method does is that it takes every character from the start index to the end index -1 and outputs it as a string, as a substring. So for this instance, the end index -1 would be 6 minus 1 would be 5, and the start index would be 3. So the characters 3, 4, and 5 are outputted. And this refers to the. Notice also that these characters have to be continuous. For example, for any calling of the function substring, you can't have like B, H, B, or like T, E, U, or something like that. They have to be in a row. For example, T, H, E. So in this instance, characters 3, 4, 5, what would that mean? If we use the same format of assigning an index value, starting from 0 to whatever the end value is, to every character in the sequence, this first B would be 0, this O would be 1, this second B would be 2, this T would be 3, this H would be 4, this E would be 5, and so on. So characters 3, 4, and 5 would refer to the T, H, and the E, so it will be returned as the. And notice that since it returns a substring is still a string, so the return value of calling the method substring would be a string, and its parameters would be 2 integers. However, sometimes you just want the start index to end, and you only need 1 parameter, because the end index can be found by using the not_length function, so it's kind of not needed, right? You could do that, but basically what substring method does is that if you don't include an end index, if you don't have the comma here, comma end index, then it just assumes that you want everything from the start index to end of the string. So we use the same string and we do dot substring 3. So it just returns every single character in a string from 3 to the n. We know that from above that the third character with index 3 in this instance would be the t. So it returns every single character in a string from t to the n. Oh, I guess I went kind of fast on that, but are there any questions? No questions? Okay, so I wanted to show a few things of using a substring in an actual program, I guess. So I wanted to, this will be sort of like a demonstration or something like that. And it's relatively simple, so I'll just use REPL, I guess. And if there are any questions, hopefully this makes it more clear. So we open up a REPL. I would just basically review all the concepts we went over, but in like context, I guess. So as I said, you can construct a string in two ways. You can construct it as a primitive, in which we would do something like string name is equal to Bob the builder. Right? This works, as I demonstrated earlier. But you can also do something like string name equals new string Bob the builder, and this would be what we call a constructor. This is a constructor method, the new string, whatever. So this does the same thing as if we just set it equal to, but this works for every single object. However, the string is an object and also can be initialized as a primitive. So now we have name pointing to some value, Bob the builder. So I don't know, quick check. If we print name, what we get? We would get Bob the builder, right? Supposedly. Yeah, okay. See? So it outputs Bob the builder, everyone's happy, everything's good. Yeah. Okay, so for a demonstration. Okay, so Bob the builder dot substring 3 to 6. So we create another variable, string substring equals this, right? And then we output substring. We should get the, right? Because that's what we calculated during our slides. Can we try that? Substring is a keyword, and you can't use keywords as variable names generally. So that's actually not a very good variable name, but we can see it works. It outputs the, which is what we expect. And then the last comment I made while talking about the last slide was that going to the end of a value doesn't really matter because we can calculate how long the string is using the .length command. So first we test how long is this? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12. So 12 plus 1, 13. It's 13 strings. So if we set 3 to 13, it should print out everything from 3 to the n. So it prints out everything from 2 to the end because 13 represents the index one past the last index. But this is the same thing as if we do string substring is equal to Bob the builder dot substring 3 comma name dot length. Because name.length calculates how long the string is. I do not allow unmute, but you can type any questions you have. Name.length refers to how many characters there are, and since the index starts from 0, it would naturally be one past the index of the last character, and thus it would go from 3 to the end as well. But since it is so easy to calculate what it takes to go from the start index to the very end of the string, what Java basically does is that if the second part of the parameter is not given, it assumes that it goes to the end. So yeah, we can test that. If we don't have a second parameter, it just goes from the third character to the end. See, it works, the builder. So basically, what I showed here is 3 ways to output the from a start index to the very end of the a string using the various commands that we learned, for example, .length or .substring or anything like that. So hopefully that makes sense. Clarifies why I said that it was unnecessary for there to be an end index in every scenario. Okay, so we still have some time, and string methods aren't that complicated, so hopefully you guys are able to do some practices. So go to codingbat.com, the same site we used last class. Go to string 1, and we can do starting from make outward. So hopefully you guys are following along. I will start promptly, and then basically what we can do is you guys can try to find the solution yourselves. And if it doesn't work, I will catch up to you guys, and you guys can see the solution that I use to make it work on screen. Also first, are there any questions about all the string methods? Your computer has no internet, then you wouldn't be able to be on the Zoom. Unless you're on a phone, in which case you can just follow along, I guess. Yeah, that makes sense. Are there any other questions? Well, I guess like in general, just please let me know if you are confused about anything. I know that sometimes I can go a little too fast when talking about things because I go over a good portion of content every class. So yeah, feel free to ask me any questions. Okay, so hopefully you guys are here already. Just go to codingbat.com. Hello, word and tags and stuff like that. Where's the hello world word and tags and stuff like that? Oh, when you construct I'm assuming you're mentioning this part or whatever. When you construct a method, in both BlueJ and most programs, they automatically does this for you. This just constructs a class for you, and within the class, you can write methods and all of your code. So this creates a class, and this creates an object within the class, a main method. Yeah, so just don't worry about it that much. And if you need to write it, just write the same thing because it's always this. Can I use REPL.it to do the code later? For this class, sure, because all of this is string and none of it has to do with object-oriented programming. Okay, so I want to do at least one example before the class ended. Okay, so we want to, out is a 4-letter word. So we want to split out into 2 substrings, the end and the front, and then do front plus word plus end. That's basically what the thought process behind doing this program would be. So we do something like create a new variable, I don't know, string front equals to out dot substring o2. Notice from class before, the start index would be 0 and the end index would be 2. So would output every single character from the start index to the end index minus 1. So in this instance would be 0 and 1. So would output the first 2 characters. We do the same thing for the back end. Substring is the method I went over in the slides. It allows us to take a part of a string. For this instance, if we want to find the last 2 characters, we could do 2, 4. However, as I noted before, if there's no second parameter, it just goes from the starting index to the end, which is what we want in this instance. So this should work. Filtering, not sure if that's an apt analogy. What? Okay, yeah, so this works. Let's see if okay, so I guess this is pretty much all I have for today. I want to go over a few more exercises, but I don't have time and Zoom is going to cut me off, and I didn't want Zoom to cut me off like it did last time. So hopefully you guys understood a little more about strings, and I will post everything from this class to the next to Google Classroom. So yeah, you can email me any questions you have.